We're going to expand this logarithm. So I've got log base 3 of x cubed y to the fourth, but in order to do this, we need 3 logarithmic properties. There is one for a product, so I've got log base a of x times y. This is equal to the sum of logarithms. Log base a, that's any base, x, plus log base a of y. I can also do one for a quotient. So if I have log base a of x divided by y, it's really similar, but this one's a difference. So log base a x minus log base a of y. And then finally, we've got the logarithm of something with a power. So this third one in yellow is going to be log base a of x to some power n. I can bring that power out in front. So this is n times log base a of x. Okay, let's go ahead and apply these to our problem. As we're working through this, the very first thing that I recognize is that this is a product. I want to go ahead and apply that product property first. I'm going to apply the product property first, and I end up with log base 3 of x cubed. I'm splitting it at the multiplication sign, plus log base 3 of x to the fourth. Next, I'm going to work with those powers. I am looking at that third property now, and I can move the power 3 out in front and the power 4 all the way out in front. This is going to give me 3 times log base 3 of x plus 4 times log base 3 of y. There's nothing else that I can do. This is my final answer. For this next one, let's go ahead and expand again. This time I'm going to do it with a quotient. I've got x square root of y in the numerator and a z to the fourth in the denominator. Well, the first thing that I notice is that this is sort of overall something divided by something. So I'm going to go ahead and use my second property here, the logarithm of a quotient. So I'm going to split this up, numerator and the denominator. So the natural log of the numerator, that property says to subtract the natural log of the denominator. That is a z to the fourth. Now that z to the fourth is pretty easy to simplify. I just need to move that 4 out in front, but I need to work with the first natural log a little bit more. Inside here, there is a product. So I can go ahead and stink that multiplication symbol there, and I'm going to use this first property to split up the natural log of x radical y. So we can rewrite this as the natural log of x plus the natural log of the square root of y. Now that took care of this first logarithm. You can see that I split that into a sum of logarithms. And for the natural log of z to the fourth, let's move that 4 out in front. So I get 4 natural log of z. So I've got almost everything finished, right? The natural log of x, nothing left to do. For natural log z, nothing left to do. But I've got this square root inside of the second logarithm. Well, a square root, so this square root of y can be written as a rational power, as a 1/2 power. There's a little index of 2 in there. A cube root would be a 1/3 power. A fourth root would be a 1/4 power. Well, that's going to make my job a lot easier on the second natural logarithm. So I can write this as the natural log as y to the 1/2 power. So now I've got a power that needs to come out in front, and I can go ahead and bring everybody else down. Here comes our final answer. So we get the natural log of x. I'm going to bring that 1/2 out in front. So I get plus 1/2 natural log of y. And then we had that minus 4 natural log of z, and we've got our answer. Let's do another one. For this next one, we've got a lot going on. We're going to do a common logarithm. I'm going to put a quotient inside here, and I have got x cubed y to the fourth divided by the 5th root of z squared. I'm going to start this exactly like I had started the last one. If you're feeling really good about these, pause the video and then come back and see how you did. Otherwise, you can follow along with me. Overall, inside this logarithm, I have a fraction. I've got something divided by something. So I'm going to use that second property first. As I break this up, I get the log of the numerator, so log of x cubed y to the fourth. Notice we've got that product inside that we're going to need to deal with, minus log of the denominator, which is the fifth root of z squared. Let's deal with the fifth root of z squared here. The fifth root of z squared, we know that that fifth root is a 1/5 power, but 2 is also part of that power, so I can change this into a rational exponent. The power on the inside is the numerator. The power or the index for that root is the denominator. So I'm going to change this into z to the 2/5, which is great because I'm going to be able to bring that 2/5 now out in front. Now for that first logarithm, I have a product. Now, if you're getting good, you can do this in fewer steps. I'm going to go ahead and step it through though, but feel free to get ahead of me. Let's go ahead and deal with this product next. So as I split that product up, I'm going to get log x cubed plus log of y to the fourth. Let's go ahead and write that last logarithm with the 2/5 out in front. So minus 2/5 log of, that only leaves the z on the inside. I only have one more step to do, and that's to apply this last property. Let's go ahead and bring each of those powers, the 3 and the 4, out in front, and here comes the final answer. So I get 3 log x plus 4 log y minus 2/5 log z. Now we've expanded some. Next, let's look at simplifying. So I'm going to take one that's already expanded and we're going to put it into a single logarithm. In this next one, we've got 2 log base 3 of x plus log base 3 of x plus 1. Combining into a single logarithm is our goal, and this is a really important skill for solving equations with logarithms. So I've got a little work to do before I can do that. Namely, I've got that 2 on the outside. So I'm going to bring this 2 as a power of the x. So this now becomes log base 3 of x squared plus log base 3 of x plus 1. Now that I've got the log base 3's by themselves, nothing multiplied out in front, I can go ahead and use my first property. This is a sum of logarithms, so I can combine it into a single logarithm of their product. So we end up, as we apply that property, log base 3 of, I'm going to multiply those values together, x squared times x plus 1. Now we're simplifying, so let's continue to simplify this. There's only one more step that I can take, and that's to distribute the x squared through inside those parentheses. So my final answer is going to look like this. Log base 3 of x squared times x is x cubed. X squared times 1 is x. Let's combine another one. This one is the natural log of x plus 2 plus the natural log of x minus 2 minus the natural log of x squared minus 4. Okay, so let's go ahead and start combining. I notice that I've got this sum right here, so I'm going to combine these first two into a single logarithm, multiplying those two arguments, the quantities in parentheses, together. So I have the natural log of x plus 2, x minus 2, minus, I'm going to do this in another step, but you could have put that into the denominator in this step as well if you recognize that. Next, I want to use, I've got this minus sign, so I need to combine these two into a single logarithm using their quotient or a fraction. So as I rewrite this, I get a single natural logarithm of a fraction. I have x plus 2, x minus 2 in the numerator, and then x squared minus 4 in the denominator. Now I'm not going to stop there because I want to simplify. I'm going to multiply out that numerator. As I multiply out the numerator, I end up with x squared plus 2x minus 2x. So I get x squared minus 4 divided by x squared minus 4. I can keep on going. These cancel each other, so I can cancel these. So all of this gives us just the natural log of 1, and the natural log of 1 is just 0. So all of this has an answer of 0. Memorize these properties. You are going to do great. Thanks so much for watching.